All right, so now it's exciting because you guys are going to get to see why we spent last week reducing radicals and talking about square roots and all that good stuff. Now you actually get to apply them. And we're going to talk something called the Pythagorean theorem, which you may have talked about in middle school just because some people like to talk about them in like the 8th grade. But if you didn't, that's okay. We're going to go over it again, and you're going to do it pretty much for the rest of your life. I even put on here, this could be the most well-known math formula ever. I think that's true. Like if you talk to your parents and stuff, most people remember the Pythagorean theorem, and it's very famous. In fact, it's so famous, you may have seen it in movies growing up. I've got one to show you here if you'll wait just a second.
I hereby confer upon you the honorary degree of PhD. PhD? That's Doctor of Thinkology. Sum of the square roots of any two sides of an isosceles triangle is equal to the square root of the remaining side. Oh, George, I've got a brain. Why, anybody?
So, as you can see, it's a pretty big deal. And you may not have understood what the scarecrow was saying, but that is kind of the point of this video, is to take something complicated and try to break it down and figure out exactly what it is. So we're going to start by just writing out, what is the Pythagorean theorem, and then I'll talk through this a little bit. So a squared plus b squared equals c squared. And so the idea is that if you have a right triangle, which you might want to go ahead and write a little box down here for a right triangle. If you have a right triangle, the relationship of the three sides is such that you can square this side and add it to the square of this side, and it's going to equal the square of the hypotenuse. So it would be like a leg squared plus another leg squared equals the hypotenuse squared. And if you forgot what a hypotenuse is, it is pretty much always just the side that's across from the right angle. So here's the little right angle in the corner, and if you look across, that one's the hypotenuse. And this is just a visual to show why the Pythagorean theorem works. There's some popular ones that are called Pythagorean triples, and these are good to memorize because then you won't even have to do your formula over and over and over again. But I think that the most popular ones are probably 3, 4, 5. So this would be, what this is saying is that one of the legs is 3, the other leg over here is 4, and the hypotenuse would be 5. So this is just a famous Pythagorean triple. Another one that shows up is the 5, 12, 13. I see that one a lot. And so it's the same idea. This one would be 5, this one would be 12, and this one would be 13. And if you plug these numbers into the Pythagorean theorem for A, B, and C, it's a true statement. So 3 squared, if we were to plug in, let's call that the A, and that might be the B, and that would be the C. This would be a true statement once we plugged it in. So we would have like 3 squared plus the B is 4 down here. 4 squared is equal to the hypotenuse 5 squared. So let's just make sure that that's true. 3 squared is 9. 4 squared is 16. So what is 9 plus 16? Well, it would be 25. And so this side would be 25, and this side over here is 25, and so it's a true statement. And anytime you find a true statement like that, then you have in fact just proved that you have a right triangle, okay? And in fact, in this box right here, let's do this. Let's say this is, you could either write helps determine right triangles if you want. We'll write that, actually, I think there's a box for it later that we could write it in, so let's see what that turns out to be. Yeah, here we go. What good does it do me? Well, the first thing is it helps you identify a right triangle. A right triangle. Okay, I'm just going to use that sign for triangle because I'm lazy apparently and I don't want to spell it out. Okay. The second point is that if you know it's a right triangle, you're going to be able to find the sides of the right triangle. Okay, and that's what you're going to see us doing with this today. Okay, so what should I keep in mind? Well, what we should keep in mind is that the hypotenuse is always the largest side of the triangle. Largest side of triangle. And that's going to be important because if somebody gives you a list of numbers, you want to make sure that the biggest number is the number that you put on the hypotenuse, because and you can even see it from the picture. This is definitely the longest side. So it should be the biggest number, okay? So keep that in mind. And the whole set it up before you math it out. Okay, basically what I'm saying here, guys, is please draw a picture, okay? Drawing a picture is gold, and you will never mess up if you draw a picture. And the reason you want to draw a picture is because if somebody tells you, like, A is 7, B is 24, and C is 25. You want to be able to look at these three sides of a triangle and be able to draw something and put these in the right place. So if you draw your right triangle, okay, let's go with biggest number first because we just talked about it over here. The biggest number is 25. So if it says C is 25, you could call this C, or you could call it 25. And then you've got a 7 and a 24. So just kind of make it look to scale. So the 7 would probably be the shorter of the two. And then their B equals 24 could go there. So that's going to be important, is just drawing this out before we do any math, okay? Now, how are we going to do math? Well, you could be given a picture and then asked to find the hypotenuse. So in other words, they could draw something for you, and there's your little right angle, and the hypotenuse is going to be the thing that you don't know, and you're going to have to find it. So they will give you information about these other sides, otherwise it's going to be like super hard. So let's pretend that like there's like, oh, okay, this one's a 4 and this one's a 9. Let's pretend that that's the problem. Okay, so if you need to find this side, you have to recognize, you know, what is the A, the B, and the C. Well, the C is always the hypotenuse. And I'm going to just write that right there. So C is always going to be your hypotenuse. So stick a C on the hypotenuse, but these two right here, they could be A or B. And it doesn't matter where you put the A or the B. I'm just going to put A there and B there, but it doesn't really matter. And then all you have to do is plug these numbers into your formula. Okay, so this is the big Pythagorean theorem that we wrote on the other page. So let's plug in. So my A is a 4, so I'm going to do 4 squared plus my B is a 9, 9 squared, equals, now C I don't know it, so I'm going to recopy the C and the squared, okay? So now we got to find this, so how would I do that? Well, this is 16, 9 times 9 is 81, we still don't know C squared, and now we got to math that out, so let's see, 6 and 1, that's a 7, and that's a 9. So 97 is equal to C squared. You may remember from last week, we had a few problems where I would have a number equals x squared. Well, now it's a number equals c squared. It's the same idea. If you want to get the variable by itself, so if you don't like that squared and you need to get rid of it, just take the square root of both sides. So c equals the square root of 97. And what you would do here is you really would think through, can I reduce this? Like, does 4 go into it, or 9, or 16, or 25, just like we did? I don't think anything's going into that, which means you are finished. That is your answer, and it cannot be simplified. If you could simplify it, simplify it. Okay, and now the next one. Given a picture to find a leg. So now maybe you're given a picture and one of the legs is missing. So let's say that like this is missing, and maybe that's a 3 and maybe that's a 5, okay? So if this is the problem given, we do the same thing. Your hypotenuse, identify the hypotenuse across from the 90-degree angle. That one is always C, so now we know C is 5. And then A or B, these are interchangeable. So I'm going to call the question mark A and this one B, but it really doesn't matter, okay? And now we're going to plug into our Pythagorean theorem, okay? So when we do that, we're going to have A squared, which we don't know the A, plus B squared, my B is 3, equals C squared, which is my 5 squared. And from here, we're going to try to figure this equation out. So let's simplify what we can. 3 squared is 9. 5 squared is 25. And you're trying to solve for A. So you're going to want to move the 9 to the other side, which means subtracting 9. That way it gets it to the other side. And on this side, you have an A squared left. And on this side, 25 minus 9 is 16. We need to get the squared off the A. So square root, so A would equal 4. Now we should have known that because if we had looked back at our earlier page, this is one of the famous ones that I was telling you about, the Pythagorean triple. So if we had really memorized these early, then on a problem like this, we could have just totally skipped all the work and said, oh, that's going to be 4. So it's good to memorize sometimes. Okay, the next one is verifying if the triangle is a right triangle. So in something like this, you may be given like a list of numbers, okay? And they're going to say, you know, do these 3 sides make up a right triangle? Well, the biggest number has to be the hypotenuse if it's a hypotenuse. So when you go to call them A, B, and C, make sure the biggest number gets the C, and these can be AB or BA, whatever you want to do. And to verify if the triangle is a right triangle, the Pythagorean theorem must be true. So in other words, when you plug these numbers into A squared plus B squared equals C squared, this needs to be a true statement. So just make sure, does the left side actually equal the right side? So let's do the math. 2 squared is 4, 4 squared is 16, 7 squared is 49. Well, does 4 plus 16 equal 49? No, big fat no. So this would be false, and if it's false, I would say, is this a right triangle? Not a right triangle. But if you had had a list of numbers, everybody, and it was a true statement, then you could say, yes, it is a right triangle. Okay, the last part of this is application. So I know people don't like word problems, but for real, y'all, if you draw these out, these are like a piece of cake. These will be the easiest word problems you do. So let's talk application. If you have a 12-foot ladder propped up against a wall, so let me go ahead and draw my wall first. It's going to be my wall. And I'm propping a ladder up against a wall. So I'll go ahead and draw my ladder here. Okay, that kind of looks like a ladder. Okay, and it says that the ladder is 12 feet long. How far out from the wall is the base? So it's saying how far is that? If the top of the ladder hits the wall 8 feet from the floor. So it means that where you're hitting the wall is 8 feet from the floor. So I know this leg is 8. I don't know this leg, and they gave me the hypotenuse. So notice I just snuck a right angle in there, and that's perfectly fine because that's how the right triangle looks like a right triangle. And when the wall meets the floor, it's 90 degrees. I haven't seen a wall that doesn't meet at that angle. So that's what we're going to do. Which of these is the C? Well, the hypotenuse. Is the 8 the A or the B? It don't matter. So I'm going to call it A. And this one that I don't know, I'm going to call this B. So just like we did a second ago, 8 squared plus the B squared that I don't know equals C squared. And then I'm going to math this out. So this is 64 plus B squared. Okay, 12 times 12, 144. Now, how do I solve for the b? Well, I need to get rid of 64. So I'm going to subtract it over, and I'm going to get b squared equals, that'll be a 0. I think that's 80. And then now, to get the b alone, I need to take the square root of both sides. So square root of 80 is my b. Now, I don't want you guys to leave the answer this way because I can already tell that this simplifies just like we did last week. So let's think of some numbers that go into it. I know for sure 4 goes into it. I wonder if 16 goes into it. I think it does. I think this is 16 times 5. So I'm going to break that down like we did last week. So the square root of 16 is 4. And the square root of 5 is the square root of 5. It doesn't simplify anymore. This is the answer. And I'm going to put feet because we're talking about feet in this word problem. So that's how you want to write your answer, okay? Okay, for the last problem, on the last one, I'm going to let you read it here, and I'll read it too. A room is measured out, and your position in the room can be expressed as if it were on a grid. Okay, so I'm going to I don't see an x and y axis, so I'm totally making one up. Okay, this will be my y-axis, and this will be my x-axis. And now that you know that, just make up your own on your paper. Let's actually plot these points. Okay, so my position is 1, 6. 1, 2, 3, 4, 5. So this is me. And my teacher is at 10, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2. So go ahead and draw you and the teacher, or me and the teacher, whoever, in the room. And this is asking how far away are you from your teacher? Well, that just means that the goal here, everybody, is to do like a straight line distance away. So it's like, what is this distance? And this problem doesn't want you to pull out a ruler, okay? You're not getting a ruler out. That would be silly. We're going to do math to figure it out. Now, the way we're going to do this is once you play connect the dots, let's let this be our hypotenuse, okay? And we're going to call that C. And I know you're thinking, but there's no triangle. Well, you get to make a triangle. So just kind of go to the end and make a straight line down to where it's the bottom of this leg is going to be even with this other point. And then we can make another line right here. Okay, looky there. We've just made our own right triangle out of this picture. And now you just label and figure it out. This is 1, 2, 3, 4 down. That's a length of 4. This is a length of 1, 2, 3, 4, 5, 6, 7, 8, 9. And now we're trying to find our hypotenuse. So a squared plus b squared equals c squared that we don't know. And we're just going to solve it. So 16 plus 81, and that would be 97 again. Oh, I really like that number today. Okay, so 97 is c squared, which means this is the square root of 97. Remember, you got to take the square root of both sides. So this is the square root of 97 away me from my teacher. And, you know, I know that's a weird number to look at when you're thinking about a distance, but remember, this is just somewhere between 9 and 10. So it's a 9 point something. And if it makes you feel better, look on the calculator, and you will be 9 point something units away from your teacher. But you can leave it like that. That's a perfectly good answer. Okay, we'll try the problems. I use this notes guide to help you out, and hopefully all goes well.